Hello guys, welcome back. In this video, we will do the A16 problem section A of IIT MS 2021. This problem is really easy. It just revolves on the basic aspects of probability and the properties of probability. So I think it will not be a problem for you to do this problem yourself. So if you haven't done this problem till now, please stop the video, pause the video, and think about it before moving on to the solution that I explained to you. Okay. So the problem is given here is that E1, E2, E3 are three events with certain probabilities. Probability of E1 is 4 by 5, probability of E2 is 3 by 1 by 2, probability of E3 is 9 by 10. So which of the following results are true? If you try to understand this, it's four options are given. So option doing with the options is one of the best ideas over here. Try to understand like whether then just try to explore the options over here. Probability of E1, E2, E3, you must understand something. These numbers on the right hand side are given very, what should I say, in a very systematic and a very intuitive format. Because you understand E1, U2, U3, and 9 by 10 is E3. Okay, so you need to equate with that. So probability of E1 union E2 union E3 is greater than equal to probability of E3, which is true in fact because E3 is a subset of this. So this is true. So it's asking to be false. So it's true. So this is not false statement. Let's see. Probability of E1 union E2 is greater than probability of E1. That is true, of course, because 4 by 5 is E2, E1, and it's really, really true. So therefore, it's not false. And probability of E1, E2 in intersection E3 is less than equal to probability of E3, E2, which is half. So it's also not false. So therefore, what we have left is this following event, that this probability is less than equal to 1 by 6. And yeah, so this is the false statement over here according to the whole like problem over here, but I would like you to explore why this is false. Okay, you can do it by, so you must think about it why this is false according to from the following definition. Is it really false? Can you construct an example? Does this imply it's this is always this? Think about this. Okay, this is really important. So a hint would be to understand the corresponding, let's see, uh, understand that probability of E1 plus probability of E2 is equal to probability of E3. I don't know whether it's a hint or not, but that's an important idea over here, I guess. No, it's not actually equal to. It's much more greater than that. No, I'm sorry. So yeah, probability of E1 plus probability of E2 is not that. Okay. Makes sense because both of them are greater than half. So you think about this: why this is less than equal to 1 by 6 is false. Like what happens if it really happens? So one of the example can be, say, it's maybe less than equal, or maybe it's greater than equal to, what should I say? It's not really understandable for this from this information actually. Let's see if it's, if E1, E2, E3 are disjoint, it's also not possible. But okay, we can think about it in this following aspect. It's probability of like probability of intersection. You can use the corresponding idea of principle of inclusion exclusion, that probability of E1 intersection E2 intersection E3 is equal to probability of E1 plus E2 plus E3 minus union minus the individual intersections. Okay, and plus those, and you can, I think you can get an information from there. Okay. Yeah, so maybe you need to find an lower bound for that. I think that's really possible. I think that's easily possible. Yeah, I believe so. Yep. So yeah, so that's interesting. So see you in the next video. Think about it. What I personally think, we can try this a bit. Probability of E1 union intersection union E3 is equal to probability of E1 union E2 union E3. Okay, see, this is much more interesting, that we should go into the depths of the problem. That's why I didn't leave it here, but I'm not sure whether it will lead to the actual solution or not. E1 union E3. Yeah, union E3. So think about that. We are sort of subtracting 3. So this intersection is sum of the all the three minus the intersection. Sorry, it's not the union, it should be the intersection. So we are subtracting this intersections part minus probability of E2 intersection E3 plus probability of A1 plus probability of E2 A1 probability of E2 plus probability of E3. So we get this result over here, and we get this result over here. It's equal to this. That makes a lot of sense. So what we can do over here is now um, we can yeah we can actually take this subs like take the do the inequalities over here. Okay, we can actually impose inequalities from the given problem that just like it has been given. Let me just show you something. Just give me a minute. This was a thing I was planning to show you. I mean, the verification of this, so that I don't make a mistake. This is the thing. Yeah. A union B union C is equal to this. So yeah. I think there was some mistake over here. Yeah, there was some mistake over here. So A intersection B is minus of this. A intersection B is minus of this and plus of all this is equal to A intersection B, I guess. Yeah, this is not there. So yeah, there are some mistakes over here. So I'm rubbing this off. So we get this following result, and therefore what we get is that we have probability of A1 the unions. So what we need to find is that we need to find a lower bound, so that we need to find a lower bound which is greater than 1 by 6. Okay, so that's what we're required to find. What we can do, we need to find a lower bound for this. Iska probability. We need to find an upper bound for this because its negative is there of individual of them, and we need to find a lower bound of this A intersection B to get a lower bound of all of this. So let's see. I'm not sure what will we get, but we can understand that probability of E1 union E2 union E3 is greater than maximum of all three of them. So maximum of all three is 0.9 is one of them, 4 by 5 is 0.8, and it's 4.5. So 0.9 is true. So we can take this inequality over here. This inequality we can take it, and so we can get that this is greater than equal to 0.9 minus A minus B. We know this result. So A union B. So we get this following result. So we are doing it this problem to the fullest. So we have got that probability of E1 union E2 union E3 is greater than equal to 0.9 minus of probability E1 minus probability E2 minus probability E3 is equal to actually minus 0.9 and minus 0.5 minus 0.8, and probability of E1 U intersection E2 plus probability of E1 intersection E3 plus probability of E1 E2 intersection E3. We need to find a lower bound for this. but here it's given upper bound. So yeah, this is a big problem over here, a bit of problem, but I think it's manageable because we can again do it union with the unions of these numbers. Yeah. So what we get over here is that, let's see, probability of E1 intersection E2 is equal to probability of E1 union E2 minus, probability of E1 union E2 is equal to probability of A minus of this. So you get minus of this plus probability of E1 plus probability of E2. Okay. So you get similarly, so sum of all of them, probability of E1 intersection E3. These are all by principle of inclusion and exclusion, plus probability of E1 times E3 and probability of E1 times E4, sorry, E2 times E3 is equal to minus of probability of E1 E2 times E3 plus probability of E2 plus probability of E3. So you get the sum of it and you get twice probability of E1 plus union E2, E3 minus probability of E1 union E2 minus probability of E1 union E3 minus probability of E2 union E3. This is becoming a bit longer than I expected. Actually, this was not in my plan to discuss in the video, but yeah, I sort of thought of discussing this with you. This was not written over here. Okay, so what we have over here is that the sum of all this probability of E1 union E2 union E3, summing this all up, we get the following actually. Minus of this, so we get the following actually, greater than equal to the following. Not greater than equal to, actually this sum. E3, because minus of that and plus 2 of this, so we get that, and minus of probability E1 union E2 minus of probability E1 union E3 minus of probability E2 union E3. So yeah, we need to use an upper bound and lower bound in each of this. That makes a bit of sense. So this is greater than equal to, so we have this is greater than equal to the maximum of this. This we have, so we need to find less than upper bound of this. So how we can find upper bound of E1 union E2? That's a challenging part. Upper bound of union E2 is actually less than equal to probability of E1 plus probability of E2. I'm not sure if this will really work. But that is turning out to be negative, so it will not really work. So this is not really working out here very nicely. Of course, I'm not saying that. So this is the where it's stuck. I'm not sure how will I how essentially we can go ahead with this without the further information, uh, because I think we should have done it earlier to explain this in the video. So if I get this solution, I will share it with you in the comment section. And if you have any ideas, please share it with us. how to show that it's actually less than equal to, either it's really false or really true or can't be commented from the given information, we should know that. But is the question is false or maybe false? Just is false. So yeah. Okay. So we must check it from here. Okay. So see you in the next video. Don't forget to subscribe and comment your ideas over here. And yeah. Bye bye.